Hey math kids, today we're going to talk about how to use trigonometric models, and unlike that last section, this one only has one example, but it's kind of involved. So it says the height of the tide above mean sea level on January 24th. So I don't know if this is important, but we will write down January 24th. At Cape Town is modeled by h of t is equal to 3 sine of pi 6 t. And that's measured in meters, where t is the number of hours after midnight. So like 1 a.m. is 1 for t, and 2 a.m. is 2, etc. Noon would be 12. Okay, so the first thing they want us to do, they want us to graph in between 0 and 24. So we're going to draw a graph, and it's a sine function. So we go like this, and one period is 12, and the way that we know that, so this should be 12, but let me show you how we know that. We take the original period of pi, divide it by pi 6, and so that's like saying 2 pi divided by pi 6, and then we flip that and multiply. So our pi's canceled, 2 times 6 is 12. So one period of sine is 12. So we'll keep going. Let's zoom out a little bit. Okay. And then that's 24. Because we were asked to go in between 0 and 24. Okay. Now, we also need to worry about the height. This tells us the height. That's our amplitude. So that's going to go from 3 to -3. And that's going to go across those peaks and valleys. Okay? All right, so that's essentially it. And then part B says, when is high tide and what is the maximum height? So half of this, that's going to be a 6. Half of that's going to be a 3. So this one's 9. Halfway in between there is going to be 18. And so halfway in between there is 15. And halfway between there is 21. Okay, so when is high tide and what is the maximum height? So we see that we get high tide here and here. So that corresponds to 3 a.m. and also 3 p.m. Okay. And then the height, because from here to here, is 3 meters above the mean. So that's all we really know. Okay. So we'll just say 3 meters. 3 meters above the mean. Okay. Okay, so now C, what is the height of the tide at 2 p.m.? So on our graph, 2 p.m., oh, that's not 2 p.m. 2 p.m. right here would be 14. So we want to know the height right there, which actually would be the same as 2 a.m. So if that ended up being easier, we could do that. But all we really need to do is plug in a 14 into this function. And so we're going to get 3 sine pi times 14 over 6. And 14 over 6 is going to give us 7/3. So 7 pi thirds. And so we go to our unit circle. and we look for 7 pi thirds. So if we're just estimating pi to be 3, that's like a 7. And so what's going to happen is we go around to our 6, because this is 2 pi, which is roughly 6, right? And then this is like 1.5. And so if we're rotating around that, we actually, they're nice and they let us use a calculator. So let's do it that way. So we could do it the way I was doing it, but they're going to let us use a calculator on this one. And that's much easier. Okay, so first thing, make sure that you're in radians. And we are going to do 3 sine of 14 pi divided by 6. And we get 2.60. 2.60 meters above the mean. Okay, and that's it for that one. And then D, a ship can cross the harbor provided the tide is at least 2 meters above sea level. Let's see, when is crossing possible on January 24th? Okay, so essentially we draw a line, and this isn't going to be perfect. Anyway, we draw a line across. We just see how many times it intersects and where it intersects. So I'm going to go back to my calculator. We are going to graph. And so we're going to say 3 sine of pi x divided by 6. And then we're also going to graph 2, just y equals 2. And I need to fix my window, I think, yes. So I need to fix my window, but we can see the concept right here. It crosses these two places. I need to be able to see all the way to 24 though. So I'm just going to go 0 to 24 on the x. And then as far as the y goes, I only need to see, just so I can see the whole thing, I'll do -4 to 4. Our graph only goes to 3 though, right? Okay, so this is our sine wave, and then all of that. So we want to see all these places that it crosses. So second, calc, intersect. Since there's only 2 curves, I just hit enter, enter. And now I'm going to find that first place that it intersects. So I just move over and then click. And so it's 1.39. So I'll just update that, 1.3, maybe 3.9. Go back to the calculator, do it again. Second, calc, then hit the number 5 for intersect. 2 clicks because we only have 2 curves. And then click right there. And 4.61. Okay, go back. Second, calc, 5 for intersect. 2 clicks. Move to the next spot. Click. 13.4. Then we just have to do it one more time. Second, calc, we can move down to 5, which is intersect. 2 clicks because we only have 2 curves. And guess. 16.6. This one's 16. Okay, so the ship can cross when it's above those points. And so it can go, your book gets super, like, exact about this. And so, but in between 1.39 to 4.61, remember those are times, so that's kind of weird, but 13.4, oops, just 0.4, to 16.6. And so if we want to translate this into time, we think of 0.39, but remember, like, time is out of 60, right? And so if we just do 0.39 of 60, we'll figure out how many minutes that is. So get out of here, 0.39 of 60 is about 23. I'm just going to round. So this is really at 1:23, so 1:23 a.m. And then we'll do the same thing with 0.61. So we say 0.61 times 60, and I'm going to round that to 37. So 4:37 a.m. So in between there, they can pass. And then we have 13.4. So I just need to take the 0.4 and times it by 60. So that's 24. So this is like 1:24. And this is PM. These were both AM. And then 16.6. So it's going to be really close. So 0.6 times 60. We get 36 on that one. So what is 16? That is 4. And we see that they roughly gave us the same thing. Was it 36? I think it was 36. Okay, we said these are roughly the same. They should be exactly the same, but just based on the rounding, that's how it worked out. So they can go in between 1:23 a.m. and 4:37 a.m. or 1:24 p.m. and 4:36 p.m. If you need additional help, please come to Math Lab. Until then, calculator.